Let's talk about relations and functions. So all equations, if it is involving, for example, two variables, all equations are relations since it's showing the relations between x and y. X for now we use as an independent variable and y we use as a dependent variable. So based on this diagram, Venn diagram, okay, we can see that all functions must be relations. Okay, so any functions that you have, it must be a relation. But not all relation is a function. Okay, so let's see now how it works. So I present you 4 different examples here. Okay, if each example shows you 2 circles here. Okay, you have been familiar with this. The left one shows the domain and the right one shows the range. So if one value of x or of independent variable can create only one value of y or dependent variable, we have one-to-one situation. And this is a function since one value of x results one value of y. Remember about the function machine. And then if we have many to one, for example, the bottom on the left column, okay, so one value of x can create one value of y, but the other value of x, such as -2, may create the same value of y. From many to one, it is still a function. But if one of your value of your x from the domain, look at the right side, the upper one, 9 creates 3 and -3. So for one value of x, 9, it has 2 pairs, 3 and -3. So 9,3, 9,3. This is not a function. Okay, so the function only allows one value of x creating a value of y. It doesn't matter if the value of y has been, it belongs to the other x, but as long as one x doesn't create more than one of y, then it is a function. We can use the perspective of trip for your analogy. So for example, if the domain consists of the people, so the x is you, your friend, your father, and etc. And the range means the destination. So you are having a trip. And the domain is the person, but the range is the destination. So a person cannot at the same time choose 2 destination, 2 range, right? So you cannot go to Lembang and at the same time you visit Jakarta, right? So that is how function works. So for a person to go to Lembang, doesn't necessarily your father cannot go also to Lembang. So the destinations can consist of one or more x, one or more people. The range, one y. One y can consist of, can be visited by one and more people. But one people, your x, cannot visit 2 destinations or more at the same time. Yeah, I hope that helps. So if we see from the perspective of graphing, since one x can only have one value of y, it means we can check it by a vertical line. So these dotted lines vertically, this is the checking lines. If you drag the line from the left to right and you still see that the one value of x consistently have one value of y, we have a function. But see on the second graph, these vertical lines, for one value of x, there are 2 values of y here. So there are 2 pairs, 2 solutions for one value of x. It means this is not a function. The third example also, the ellipse, this is not a function. Okay? So yeah, this emphasizes how we check whether it is a function or not. See that the red lines vertically, it's showing that The first one is a function, but this one is not a function, since one value of x can have two values of y or more. So this one you can have a feeling, no, you can check that this is a function, but the circle is not.
Example about domain and range. Let me just show you that this is the domain. Okay, this is the domain. Okay, so the domain belongs to independent variables. And usually we use x, but it doesn't necessarily always x. Okay, and this one is the range. So everything inside this will be the range. So this one belongs to the dependent variable. Since you notice that dependent is dependent on independent. So this is why. Okay, so let's see this example. Y squared equals x. Since for this part we agree that the y is dependent on x, then this must be converted into the statement of y equals something, right? So since we know that y squared equals x, therefore y equals plus minus square root of x. Now, if I give you an example, if the domain is only 3 values, for example, 16, 25, and 49. Example. So the domain only consists of 3 values of x: 16, 25, and 49. Okay? Based on this function, they are all being processed by the fx, right? Fx indicates y, replace y, okay, which is plus minus square root of x. So there will be 16, the y will be equals plus minus square root of 16. Therefore, there will be 2 values, -4 and 4. Okay, just from one x, the value of y will be 2. Okay, just like the same with 25. If I put 25 into this equation as your x, so the y will be equals to plus minus square root of 25, which is the first one is plus 5, the second one is -5. Okay, so yeah. And then from 49, we can also find 2 values of y, -7 and 7. Okay, so the domain, if the domain for this function is only 3 values, but the range consists of 6 numbers. If I just put it in order, -7, -5, -4, 4, 5, and 7. So this is the range. The range mentions or describes all values, all possible values that comes for your y based on your domain. Okay? Now this situation is not a function.
A few minutes later.
So the statement of y squared equals x, it is not a function. Why? Because one value of x can create 2 different values of y. For a function, it has to be one value of x creates one value of y. How about if we change the equation into this? Okay, since the dependent variable is y and the independent variables is x, it means that this form is already being the final form. So to find what is the pairs, let me just put the domain here. Okay, for example, the domain is 1, 2, 3. Okay, so it means only these 3 that can be included for your solution. So let's put all of this value into the domain 1, 2, 3. 3. And then these values being processed by the equation. So they are being processed by fx equals x squared. So f1, so for example, f1, it is, for example, this is 1, and then f2, it is 4, f3, it is 9. One values of the domain, one value of x, create one values of y. This is a function. Okay, and for example, if I add another x into this, for example, -2. Okay, I add -2 here. So it means I need to add a guess here. Yeah. So the question is, -2 being processed by this function, -2 squared, it will be 4. So actually, it will be 4. It's the same. But still, this is still a function. Why? Because one value of x creates a value of y. It doesn't matter if there are two different x will comes out into a specific one y. It doesn't matter. As long as one value of x can create one value of y. So the conclusion is, if you have this is the domain, this is the range. Okay, if you have this kind of relation, this must be a function. If you have, for example, this is domain, this is the range. If you have, okay, this is 1, 2, and then this. This is also a function, since there is no x that creates two different y. This is a function. This is a function. And then the last one, which is not a function, if you have domain and range, okay, but there is one x that creates two y. It doesn't matter the other x just create one, but as long as at least one x can create two y, we have yourself not a function. Okay, see the difference? This is a function, this is a function, this is not a function. Okay, if I want to show you by graphing, remember, one x cannot create two different y. So if this is your graph, this is how you check is it a function or not. Just make a vertical line to make sure that one x will only have one y as its pair. For example, 2, -2. Sorry, -2. This is the y, and only one. -1. This is the y, only one y. So you can just slide, and you can be certain for any values of x, they create only one y. What is the example of not a function? Let's just erase this. For example, this one. Okay, although if I use -4 as my x, it only has one y, yes, but at a certain point, like this one, -1, -1 for its x has 1, 2, 3 values of x, values of y. This means this graph is not a function. Okay, that's how you check is it a function or not from the graph.